Hi, this is Mrs. Carnes, and this video is going to be one of two videos about compound inequalities. All of these compound inequalities are going to contain the word "and." So by definition, compound inequalities that contain the word "and" are just two inequalities that are joined by that word "and." So we're going to be talking about two inequalities here, and then we're going to take a look at what we do with them. Something else to remember, though, is when we're talking about a solution to a compound inequality that contains the word "and," we have to make sure that the solution makes both of the inequalities true. So your solution has to work in both inequalities, or it will not be a true solution. So now we take a look at this example. We have a compound inequality. It doesn't really show the word "and," but we know it's a compound inequality containing the word "and" because it's one statement that has the inequalities, two inequalities in that statement. And so we're going to split this up to be two separate inequalities, and then we're just going to join them with this word "and" here. Now the first one that we're going to take a look at is going to be the -4 is less than -2r minus 5. That's going to be the first inequality that we're going to look at. Let me outline that in blue for us so we can keep them separate. So that's the first inequality that we're going to use. The second inequality is going to be the one that starts with -2r minus 5 is less than or equal to -1. And so you can see that by breaking it up like this and putting these boxes around it, you can see that there really are two separate inequalities. Let's write the first one out. It's -4 is less than -2r minus 5. And so what we're going to do when you get your first inequality is you're just going to simply solve for the variable. Basically, you're going to use your inverse operations that you're very familiar with. You're going to add 5 to both sides. You're going to get 1 is less than -2r. You're going to divide by -2. Because we're dividing by a negative, you have to watch carefully for that. We know that our inequality symbol is going to flip. We're going to get -1/2 is greater than r. Now, if you remember from the video that we talked about when we reviewed what inequalities were, we can write it this way, or we can put the variable in front so that it says r is less than -1/2. Both of those statements mean the exact same thing. Sometimes it's just a little bit easier to read it when the variable comes first. Once we have the solution to that one inequality, we have to find the solution to our second inequality. The second inequality, -2r minus 5, is less than or equal to -1. Again, using your inverse operations, add 5 to both sides, divide by -2, and r is greater than or equal to, we have to flip the sign, r is greater than or equal to -2. And that is our second part of our solution. We combine them with the word and then together that becomes the full solution for the inequality that we started with. So let's take a look at what these look like, what our solutions look like when we put them on a graph. When we put them on a graph, we know that we're going to graph both of them separately at first, but to have our final answer, it must be on one graph. So let's just take a look at what happens here. The first inequality, we remember when it's a less than symbol, is an open circle. It's going to be an open circle at -1/2, and since r must be less than it, it's going to go to the left. That is the graph for r is less than -1/2. When you come to the second inequality, r is greater than or equal to -2, we know it's going to be a closed circle at the -2, and it's going to go to the right to be greater than or equal to -2. Well, now, in and inequalities, the solution must work in both of them. And so what we have to look at is where do these two separate graphs overlap? And they overlap from the -2 to the -1/2. And so that's the only part of the graph that will appear on our final solution when we graph this. It would be a closed circle at -2, it would be an open circle at -1/2, and we would connect between the two of them, and that would be the graph for our compound inequality that contained the word "and." Excellent job. Now the next video you're going to see is going to be compound inequalities that contain the word or. So you'll want to make similarities and differences between them so that you know how to use them. Excellent.